Okay, folks, welcome back. Quadratic functions and equations, lesson 1, connecting zeros, roots, and x-intercepts. So I'm going to say this straight away first before we even get started. Zeros of functions or equations, roots of function or equations, or x-intercepts of functions or equations are all exactly the same thing. They all mean the same thing. The terminology is just used depending on the type of question, depending on the type of equation or function that you're given, but they all mean the same thing. So as we work through these first couple of pages of notes, just kind of remember that the whole purpose of the first 3 pages of these notes is 4 pages of these notes is to get into your head that the zeros, the roots, and the x-intercepts of functions or equations are all the same thing. Okay. So that being said, let's move along. Function and function notation. So if you remember from last year, we did talk a little bit about function notation. Function notation is just a fancy way to say y in an equation, and some terminology changes around that. So if we have this function notation here, or this function in function notation, that would be the same as y is equal to 4x minus 8 in equation form. Okay, it means exactly the same thing. It's just has a bit of different terminology. So it says here, I'll highlight, here we go, function notation. Under a function, f, the image of an element x in the domain is denoted by f of x, which is read f of x. So it's fancy terminology that you really, well, you're not going to be asked for it. So it's not like you don't really need to know it, but it's just a fancy way to write y equals function notation. And when we talk about functions and when we talk about equations, other terminology changes as well, as what you're about to see with the zeros and roots and x-intercepts. And we can work with functions just like we can work with equations. So here, if it says we can show that under the function f, the image of 5 is 12. So we write f of 5 is equal to 12. What do we do to get there? We take our function, we substitute in 5, and we calculate to get 12. Just like that. Just like finding the y value if x is equal to 5. So if x is equal to 5, what do? You substitute it into the equation and calculate. Okay, so it's the same thing. And even working backwards, so you can work that backwards too. All right. We can also show that under the function f, the image of 2 is 0, right? F of 2 is equal to 0. So we substitute 2 into the function, calculate to get 0. We could substitute 2 into the equation, calculate, and get 0. It means the same thing. Okay? It's the same idea. The 0 of the function of f of x is 2. The 0 of the function f of x is equal to 4x minus 8 is 2. The root of the equation, y equals 4x minus 8 is 2. So the 0 of this function is 2. The root of this equation is 2. Although we're using an equation here and function notation here, this value is the same, correct? Hopefully you can see that. More about zeros of functions. A 0 of a function is the value of the independent variable, which makes the value of the function equal to 0. Zeros of a function can be found by solving the equation f of x is equal to 0, or y is equal to 0. What is x when y is equal to 0? Find the 0 of the function where f of x is equal to 7x minus 21. We simply say, well, the 0 of the function is when f of x is equal to 0. So I'm going to substitute in 0 for this whole f of x. 0 is equal to 7x minus 21. And then I solve for x. I'm going to add 21, add 21. Let's give me 21, not 22. 21 is equal to 7x. Divide by 7, divide by 7. X is equal to 3. There is the 0 of that function. There is the root of this equation. Okay, means the same thing. We go over the page. Investigation 1, connecting roots, x-intercepts, and zeros in a linear relation. The graph of y is equal to 2x minus 6 is shown right over here. We can put a point at minus 6. Oops, that's supposed to be a circle. There we go. We can put a point at minus 6, and we count our slope, go up 2 over 1, up 2 over 1, up 2 over 1, and we can get this line. Okay, that's how we can graph that. Determine the x-intercept of the graph both algebraically and graphically. Well, graphically, the x-intercept is the x value here. Whoops, that should be red. The x value here. Well, that coordinate point is 3, 0. So the x value is 3. To calculate that algebraically, we say, well, y equals 2x minus 6. If we are looking for the x-intercept, that is when y equals 0. So I put a 0 in for y equals 2x minus 6, and I solve for x. Add 6, add 6. That gives me 6 is equal to 2x. Divide by 2, divide by 2. 3 is equal to x. There is your x-intercept. Okay. Question B, determine the root of the equation if 2x is equal to 0. Well, isn't that the same process that we just went through here? 2x minus 6 is equal to 0. Add 6 to both sides. 2x is equal to 6. Divide by 2 on both sides. X is equal to 3. Okay, same thing. So depending on how it's written, here's the equation. Here is an equation as well, but it's equal to 0. This is what we call the root of the equation. We would call this the root of the equation actually as well as the x-intercept right there. Question C, state the connection between x-intercepts of the graph, y equals 2x minus 6, and the roots of the equation, 2x minus 6 is equal to 0. They are the same. Easy as that, they're the same. Consider the function f of x is equal to 2x minus 6. What's the 0 of the function? You should be able to straight away say, well, the 0 of that function is 3. You make this 0 and solve for x, which is exactly what we've done twice. So now you can see all this terminology is coming together to show you that they're all the same thing. What is the connection between the x-intercepts of the graph of this, y is equal to 2x minus 6, the roots of the equation, 2x minus 6 is equal to 0, and the 0 of the function, f of x is equal to 2x minus 6, they're all the same. Okay, I'd give you a nice little summary of all of that, but it's pretty easy to say, and I think it's at the bottom of the next page. X-intercept, roots of the equation, zeros of the function, all mean the same thing. Just a different usage of how the equation is laid out or the function is laid out, and the question that you get asked. Over the page, investigation 2. Still looking at that connection, except this time we're looking at it in a quadratic relation, which is what this whole unit is about. Jacques is determining the roots of the equation x squared minus x minus 6 is equal to 0. He wrote the equation in factored form and used the zero product law to determine the roots of the equation. Complete his work and solve for x. So remember I said that factoring is going to be important in lots of chapters? Well, here it is again. We need to factor x squared minus x minus 6. I know that that's going to factor by inspection to x minus 3 and x plus 2. That's equal to 0. And then our zero product law says we're going to take x minus 3, make it equal to 0, take that x plus 2, make it equal to 0, and solve for x. Add 3, x equals 3. Minus 2, x is equal to negative 2. There are your two x-intercepts for this quadratic. Okay. That means where it crosses the x-axis, right? Question B, the graph of x squared minus x minus 6 is shown. State the x-intercepts of the graph and mark them on the grid. Well, where does this graph cross the x-axis? Right there at negative 2 and right here at 3. Look, lo and behold, those x-intercepts there on the graph, as well as our work for the zero product law, those roots are the same thing. Question C, state the connection between the x-intercepts of the graph of y is equal to x squared minus x minus 6 and the roots of the equation x squared minus x minus 6 equals 0. They are the same. Explain the connection between the factors of x squared minus x minus 6 and the roots of the equation. Okay. The value that makes those factors 0 are the same as the roots, right? So using the zero product law. Value that makes factors equal to 0 are the same as the roots. And basically, we're using the zero product law. Question D, consider the function g of x is equal to x squared minus x minus 6. Determine the roots of the function. Should be able to say, hey, you know what? The roots and the x-intercepts and everything else, they're the same. -2 and 3. And then that's what's all said down here. So this is the key. X-intercepts of the graph of that, the roots of the equation of that, and the zeros of the function of that are all the same values. The same. Okay, so now when you get those questions that ask you for stuff, roots, x-intercept, zeros, you have an idea of what you're looking for. It's just, like I said, many times already I've said, just different terminology. Example 2. Fill in the following statements regarding the functions with the equation y is equal to f of x. The zeros of the functions, so zeros usually used with the terminology function. The x-intercepts of the graph of the function and the roots of the corresponding equation y equals 0 are the same numbers. Okay, the same numbers. And here's our graph again. Fill in the blanks. The graph of the f of x, the graph of the function f of x is equal to x squared minus x minus 6 has x-intercepts equal to -2 and 3 and a y-intercept of, looks like -6. The function f of x is equal to x squared minus 6 is equal to x plus 2 x minus 3 has zeros -2 and 3. The equation x squared minus x minus 6 equal to 0 has roots x equal to -2 and 3. See how they're all the same, yet the terminology in the questions is different. Okay. Example 3. Consider the equation 2x squared minus 7x plus 3 is equal to 0. Describe how the zero feature of a graphing calculator can be used to determine the roots of the equation. Well, I know you all don't have graphing calculators, but what you can do is use Desmos. So I'm going to go to Desmos, and I'm going to put this equation into my fancy Desmos app here. There we go. What's the equation? 2x squared minus 7x plus 3 equals y. And there's your graph. Okay. Now we can get lots of information from looking at this graph. So I'll just make this bigger a little bit. There we go. If you just touch on certain points, you can start to get some information. The key ones kind of show up for you. This point here and this point here, that's where my graph crosses my x-axis. Those are my zeros. Those are my roots. Those are my x-intercepts. So -0.5 and 3. 0.5 and 3. So let's go back here. So I'm using Desmos. If you have a graphing calculator and you want to know how to graph this, come and see me and I'll happily show you. but this was 0.5 and 3. It says use a graphing calculator to determine the roots of the equation and sketch the graph on the grid provided. So now we have to kind of put this on the grid provided here. So 0.5 is here. 3, 1, 2, 3 is here. There's my two X-intercepts. Let's go back to Desmos. There's our graph. This point down here, this is called the vertex of a quadratic. It's an important point. 1.75, negative 3.125. And then this point where it crosses the y-axis, that's my y-intercept, 0 and 3. So now let's try and remember those numbers. So this was 3, my y-intercept. This was negative 1.75, kind of in there, and negative 3 point something, somewhere in there. And then you would just draw a smooth curve. Now my pen doesn't draw a smooth curve, so that's the best you get. Question C, use the x-intercepts of the graph of y is equal to 2x squared minus 7x plus 3 to factor the expression 2x squared minus 7x plus 3. So you should be able to, well, we've done our polynomials section. You should be able to factor this. You're not going to get pretty answers though. So this one's a bit of a tougher one to factor. But if I know that my roots or my x-intercepts are 0.5 and 3, I can say, well, this should be x minus 0.5. This should be x minus 3. But then I need to accommodate for this 2 that's out in front here. So I stick it there. Okay. Or, and if you were to expand this a little bit, if I bomb these two together, I'm going to get 2x minus 1, x minus 3. And that's what you would get if you factored that, which is at this point fine. Okay, it's totally fine at this point. We're going to get to a process. We're going to get to a place though where we don't want values in front of this x, and that's why it's done this way. Question D, what are the zeros of the function? 0.5 and 3. Roots, zeros, x-intercepts, all the same thing. Again, I said it. Look, I'm not even going to say it again because it's right. Oh no, it's kind of right there. Not really. Finding the zeros of a function. To find the zeros of a function, you either substitute 0 for f of x, or which is y, or you graph the function and determine the x-intercepts. But sometimes we don't have a graph always to do that with. So we have to know how to do that by using algebra. And this is where our factoring comes into play. Okay, so we have to be able to factor all kinds of polynomials all over again. Okay. So let's look at example 4a. X squared plus 8x minus 33. And just from our factoring unit, I know if we're trying to solve this, I'm going to move the 33 by subtracting 33 from both sides. That's going to give me x squared plus 8x minus 33 is equal to 0. Now I'm looking for two numbers that multiply together to give negative 33 and add together to give 8. I can use inspection. I know that that is x plus 11, x minus 3 equals 0. Using my zero product law, I go x plus 11 equals 0. Subtract 11 from both sides. X is equal to negative 11. I do the same for the x minus 3 is equal to 0. Add 3 to both sides. X is equal to 3. There are my roots, negative 11 and 3. There are my x-intercepts. There are my zeros. Question B, 6 times 4x plus 5 times x minus 3 is equal to 0. The beauty of this is already factored for us. I can get rid of the 6 right away by dividing both sides by 6. The other side is still equal to 0, so I have 4x plus 5 times x minus 3 is equal to 0. So the 6 disappears. Remember, constants can disappear like that, but variables cannot. Now I use my zero product law. 4x plus 5 equals 0. I'm going to subtract 5 from both sides. 4x is equal to negative 5. I'm going to divide by 4. X is equal to negative 5 over 4. I do the same for the other factor. X minus 3 is equal to 0. Add 3 to both sides. X is equal to 3. There are my, what's this question asking for? Roots. There are my roots. Question C, 2x squared minus 8 equals 0. Two ways you could work this through. I'm going to do it using the factoring method. I know both of those divide by 2, so if I divide this all by 2, by 2, by 2, then the 2 disappears. You could factor it out. I know it factors out. 2x squared minus 4 equals 0. Now divide by 2, gives me x squared minus 4 is equal to 0. I know that's difference of squares, so I'm going to get x plus 2, x minus 2 equals 0. And then finding my zeros, I go x plus 2 equals 0. Subtract 2, x is equal to negative 2. I go x minus 2 is equal to 0. I add 2, x equals 2. There are my zeros, or my roots, or my x-intercepts. Example number 5. For the following functions, find the zeros, find the y-intercept of the graph of the function. So the zeros, remember we have to factor these and use our zero product law. Okay, and then I'll show you algebraically how to find the x-intercept. So first thing, I'm going to say, well, I want this to be equal to 0, and I know that I have a greatest common factor of 5, so I'm going to factor out of 5, x squared plus 3x minus 4. I can factor this by inspection. I look for two numbers that multiply together to give negative 4, add together to give positive 3. That's negative 4 and positive 1. No, positive 4, negative 1. 5, x plus 4, x minus 1. Using my zero product law, I can divide by 5. That's going to disappear. So 0 is equal to x plus 4 times x minus 1. And I take both of my factors, x plus 4 and x plus minus 1, minus 1. Make them equal to 0 and solve. I'm going to subtract 4. X equals negative 4. I'm going to add 1. X equals 1. There are your two, in this case, two zeros. Now, to do the y-intercept, if I go back to Desmos really quickly, sort of quickly, maybe quickly. Come on, Desmos. Oh, my equation's gone. What equation did we have in there before? Let's put this equation we're working with. 5x squared plus 15x minus 20. There's my graph. I want to see it, so I'm going to pinch and I'm going to squish it down. What is my y-intercept? Where does it cross the y-axis? Right to there. 0, negative 20. The key about this is that the y-intercept is always when 0 equals x. So the easiest way to find it, if you don't have a graph, is to substitute a 0 in for x. Just like finding the roots and the x-intercepts, you substitute y as 0. To find the y-intercept, I make x equal to 0. So in my equation, f of x is equal to 5 times 0 squared plus 15 times 0 minus 20, which is 0 plus 0 minus 20, which is negative 20. Now, eventually, you're going to need to make the connection. If my polynomial is in expanded form, this value is my y-intercept. So remember, ax squared plus bx plus c is your y-intercept. So you should be able to look over here right away and say, hey, you know what? My y-intercept is equal to 10. If I substituted in 0 for x, 3 times 0 squared plus 11 times 0 plus 10, I would get 10. There's your y-intercept. Done. Okay. Now we have to find the other parts, the x-intercepts, or the zeros, sorry. So I have to factor 3x squared minus 11x plus 10. So somewhere you're doing that factoring work. Two numbers that multiply together to give 30, add together to give negative 11. Those two numbers, negative 6, negative 5. So now I'm going to decompose. I'm going to take my 3x squared minus 6x minus 5x plus 10. And I'm going to factor. Factor by grouping, draw your T. 3x is my greatest, 3x is my greatest common factor here. Leaves me x minus 2. Minus 5 is my factor here. Leaves me x minus 2. So you can see my factors are 3x minus 5 and x minus 2 equaling 0. And I use my zero product law. 3x minus 5 equals 0. Add 5, add 5. 3x is equal to 5. Divide by 3, divide by 3. X is equal to 5 over 3. There's 1. And I go x minus 2 equals 0. Add 2, add 2. X is equal to 2. There's your other. That's question B. Question C, I'll switch colors just because I'm getting a little cramped. There's a little bit less that we need to do here. So 2x times 2x plus 1 is already factored for us. So I just need to find my zeros, 2x plus 1. I take both of my factors, 2x and 2x plus 1, make them equal to 0, and solve. Divide by 2, x equals 0. There's 1. Minus 1, 2x is equal to negative 1. Divide by 2, x is equal to negative 1 over 2. There's your other 0. My y-intercept is when x equals 0. So I'm going to go 2 times 0 times 2. Oh, I don't think I have enough room. I made it too fat. I got to start over. 2 times 0 times 2 times 0 plus 1. Well, 2 times 0 is 0. 0 times whatever this is 0. Oh, that's plus 1. This is a plus 1. So this is 0 overall. There's your y-intercept. Hopefully that kind of made sense, but it's a quick review of doing some factoring work in there as well. Over the page, example number 6. For each of the following functions using graphing calculator, sketch the graph of the functions, find the zeros as exact values, write the function in factored form. Okay, so we're going to go to Desmos, 3x squared plus 4x minus 7. 3x squared plus 4x minus 7. 3x squared minus 4x, no, plus 4x, minus 7. Change that to a plus. There we go. Okay, so we need our zeros where it crosses the x-axis there and there as exact values. So 1, 0 is fine. That's 1. Negative 2.333. That is 2 1/3. Negative 2 1/3. And then while we're here, what's our y-intercept? Negative 7. Okay. So back in our Notability app, over here, I can sketch my graph. This is going to cross down here somewhere at negative 7. It's going to cross here at 1. It's going to cross over here at negative 2.33. And I can very quickly just sketch. Done. Sketched. But we need our zeros. So this was 0. This was 1. And this was, as an exact value, 2 1/3. Negative 2 1/3. Oops. So messy. And 0. And write the function in factored form. So my factors are x minus 1 and x plus 2 1/3. Remember, exact values. and the opposite thing, right? If that's a negative, this is a negative 2 1/3, then my factor here is positive. So I'm putting in a minus 2 1/3, and it's already minus. And then we just have to remember that in factored form, we have to have this 3 out in front. If we're getting our factored form this way, 3 goes out in front. But I can't have that 2 1/3 there. It looks a little messy. So I'm going to bomb this 3 into this bracket. Give me x minus 1, 3x plus 7. 2 1/3, 6 and 1 is 7. There's your factored form. Next question, question B. This is a cubic. You won't be asked to do any work with a cubic, but it's just kind of nice to see how they kind of work. So they work the same way. Cubics, quartics, quintics, whatever you want to call them, fourth degree, fifth degree polynomials, all kind of work the same. All our x-intercepts will be factors of our polynomial. 4x squared minus 7x, sorry, that should be 4x cubed. This should be 7x squared minus 4x plus 7. Look, we get this funky graph. I'm going to squish it, and I'm going to lay it out a little bit better. There we go. We get this graph, and we can see our x-intercepts. There's 1, 1.75, there's 2, there's 1, and there's another one there, negative 1. And it crosses our y-axis up here at like 7. So we'll attempt to sketch that. And then remember, negative 1, 1, and 1.75. We're going to sketch this. This is going to go here, and negative 1, and positive 1, and 1.75. This is not to scale. There. Done. This was negative 1. This was 7. This was positive 1. This was 1.75. And then in factored form, our factors are x minus 1.75, x minus 1, x plus 1, with this 4 out in front. And then we're going to get rid of this decimal by bombing the 4 into that bracket. That's going to give us 4 times x minus 1.75 times 4 is 4, and 3 is 7. X minus 1, x plus 1. There's your factored form. Okay. Checking Scholantis or checking in class tomorrow to see which questions need to be completed. But that's your quick intro to quadratics and roots and zeros and x-intercepts. And we will see you next time.